Okay, factoring by grouping. To factor by grouping, first check for a GCF of the polynomial. So the whole thing, if needed, rewrite in standard form. So if there is a GCF, factor it out. After that, rewrite it in standard form. Okay, find the GCF of the first two terms. Find the GCF of the first two terms. Repeat for the last two terms. Like I said, it's just GCF, what we just did. Rewrite them in factored form. This is kind of crazy how this works out. Is there a GCF here? Two doesn't go into 3 and 3 doesn't go into 2. So there's no numbers. There's not an x in each one. So I can't there's no GCF immediately. Next I need to rewrite it in standard form. Has that already been done? Yes, it has. So if you look at these first two terms, this is what it said right here. Find the GCF of the first two terms. I'm going to isolate these first two terms. Is there something I can pull out here?
Yeah.
What would I pull out?
2 and x.
2 and x squared, right?
Yeah.
So that's what they did here.
Yes.
They factored out a 2x squared from this. What they were left with was x plus 3. They factored out the second half. Is there anything that's in both of these? The -1 sign. So they factored out -1. What they were left with, x plus 3. So there's a mistake right here. That's the bummer. Okay, so after I factor this, I get 2x squared minus 1. I take the two things I factored out, put them together. I take what I factored out of and put that last. Okay, so we're going to do this next example together. There is no GCF. 4 does not go into 3. There's no GCF for the whole thing. So I'm going to factor the first two terms. What can I factor out of this? 4 and x squared. Luke, could you turn that off? So that's this. If I factor out 4x squared, I'm left with x minus 5 inside. Okay, now we have the second part. What can I factor out of that? Is that a minus? That's a positive right there? Really?
Yeah.
Okay, so positive 3. And I'm left with x minus 5. These two terms are the same. So technically, I can factor this entire term out. That's how that's working. If I factor these two terms out, I'm left with 4x squared plus 3. And I'm left with x minus 5. Again, if I want to check my answer, I just multiply it all back out. Part I'm worried about, can you see where this is coming from? This part. I have two of them, so I factor this back out again. So it's just x minus 5. Okay, we're going to skip this example and move on to the first one here. Is there a GCF? Nope. There's no number that goes into all of them. There's no x in each of them. Let's factor this out. X squared. If I factor out x squared, I get x plus 2. Factor out the second part. Negative 36, negative 72. Factor out a negative 36. I am left with x plus 2. Negative 36 divided by negative 36 is a positive 1. Negative 72 divided by negative 36 is a positive 2. Here's my first term. X squared minus 36. Second one, x plus 2. Can this still be factored? This is a special case. Do you remember these? X plus 6, x minus 6. This can be factored to x plus 6 and x minus 6. If you forgot what we're doing, multiply the last two to get the last number. Add these two up to get the middle. That's just 0. X plus 2. So that is completely factored. As you said earlier, you know you're done when it can be factored no more. Okay, one more example. There's no GCF. 2 and 3 do not go into each other. I can factor out an x squared though. I get 2x plus 3. Devin, what can be factored out of this part? 25. How about a negative 25? Because these are both negative. I get 2x plus 3. Isn't that just cool how these both end up being the same? I get x squared minus 25. These two terms being multiplied to this term, 2x plus 3. This can be factored. X plus 5, x minus 5, 2x plus 3.